Welcome to my presentation. I'm delighted to have the opportunity to share with you our accepted work in the NeurIPS2023 Dataset and Benchmark Track, LAMM, encompassing Language-Assisted Multimodal Instruction Tuning, Dataset, Framework, and Benchmark. Thank you for joining me today. In the next 5 minutes, I will provide an overview of the background, dataset, benchmark, framework, key results of our work. Additionally, I will introduce the LAMM ecosystem, and we encourage you to stay engaged and follow our progress. Large language models have emerged as a promising approach towards achieving general-purpose AI agents. The thriving open-source LLM community has greatly accelerated the development of agents that support human-machine dialogue interaction through natural language processing. However, human interaction with the world extends beyond only text as a modality, and other modalities such as vision are also crucial. Recent works on multimodal large language models, such as GPT-4v and BARD, have demonstrated their effectiveness in handling visual modalities. However, the transparency of these works is limited and insufficient to support academic research. To address the absence of MLLM in the open-source community, we present LAMM-1, a multimodal instruction tuning dataset for 2D and 3D vision. 2. The very first attempt of a benchmark for MLLMs on vision tasks. 3. An extensible framework to facilitate the extension to modalities. 4. A growing community for training and evaluating MLLMs, and further empower us to cultivate multimodal AI agents. To facilitate understanding, let's examine a few examples of our data. Each sample in the multimodal instruction tuning dataset consists of an image and corresponding textual instructions. For the training data, the text comprises pairs of instructions and responses. Here, we compare our work to the first open-source dataset for MLLM, LAVA. Specifically, when considering data of the N-round daily dialogue type, LAMM's data demonstrates a greater emphasis on questioning the relationships between objects. For example, a question might ask, how are the elephant and the antelope interacting in the image? Furthermore, LAMM's data also includes inquiries about deeper-level reasoning behind the images, such as what can we infer from the image about the behavior of these animals? Similar to LAVA, we also include data from single-turn dialogues, which are more akin to image caption datasets in terms of format. However, due to the powerful reasoning and content generation capabilities of LLM, we aim for more detailed responses in our data samples. In this regard, the data quality of LAMM is better. For example, LAMM provides more detailed descriptions of foreground objects and includes the majority of background objects. This ensures that the responses in our dataset contain richer information. Due to the limitations of LLM in judging factual knowledge, we also provide data related to multimodal factual knowledge, namely N-round factual knowledge dialogue. In this type of data sample, for example, there is a focus on questioning architectural features, and the responses are provided with accurate factual knowledge from reliable sources such as Wikipedia. Additionally, LLM has its challenges in responding to visual task instructions. To address this, we utilize existing visual datasets and incorporated text templates to create one-round visual task dialogue. Currently, we are showcasing tasks such as object detection, OCR, optical character recognition, and counting within the field of computer vision. For 3D point clouds, we have employed a consistent approach to obtain these 3 types of data. However, due to the lack of annotated factual knowledge in currently available open-source point cloud datasets, we do not have data similar to the N-round factual knowledge dialogue for 3D data. Overview of our dataset, demonstrating the process of constructing our dataset using the GPT API. By designing different system messages, in-context learning pairs, and queries, we create the dataset that covers almost all high-level vision tasks for both 2D and 3D vision. As mentioned before, the dataset includes 4 distinct groups: N-round daily dialogue, N-round factual knowledge dialogue, 1-round detailed description, and 1-round visual dialogue. We end up with an image instruction tuning dataset containing 186,098 image language instruction response pairs and a point cloud instruction tuning dataset with 10,262 point cloud language instruction response pairs. An overview of our benchmark. It includes both 2D and 3D pipelines. covering multiple computer vision tasks. For each task, we provide the task definition, output structure, and a set of questions as instructions to the MLLM model. Then the entity extraction is applied on the output to extract the key answer. The LAMM evaluation is used to evaluate the model's performance, which includes traditional metrics, binary location metric, and the GPT metric. Above is the framework of our MLLM. Each modality is encoded by the corresponding pre-trained encoder and decoded by LLM. LLM is shared among modalities and trainable projection layers, and LoRa parameters are modality-specific. Below is a table for the results of MLLM on 2D vision tasks by the traditional metrics. All the MLLMs are tested in a zero-shot setting. Although MLLMs demonstrate certain abilities of recognizing open vocabulary classes, understanding images, and then answering questions, they performed poorly on tasks involving object localization, including object detection, counting, and key points detection. For more detailed results and results on 3D vision, please read our paper. As one of the very first open-source endeavors in the MLLM field, our goal is to create an ecosystem where every researcher and developer can apply, study, and even contribute. We work on various aspects, including MLLM datasets, frameworks, benchmarks, optimizations, and applications as AI agents. To be specific, we utilize PyTorch and DeepSpeed as our infrastructure since they are widely used in the field. We are still iterating on the infrastructure by practicing on training and inference optimization frameworks. Currently, we have open-source datasets that cover 2D images and 3D point clouds in natural scene domains for MLLM training and evaluation. Additionally, we have open-sourced models that include pre-trained models for each modality required in MLLM training, as well as our trained MLLM parameters for public use. We also provide comprehensive tutorials on our homepage to ensure easy adoption of the fully matured MLLM training and evaluation methods. Lastly, we are currently working on applying MLLM to embodied AI agents and are developing simulators that support data production and validation capabilities. As a fully transparent open-source community, any form of collaboration is welcome. You can scan the QR code to stay updated, and welcome to contact me if you have any question. Thanks for your attention.